Many of you have been asking about the ground symbol, so today we're going to focus on what the ground symbol in a circuit schematic is and what the purpose of ground in a circuit actually is. Now, there are different types of ground symbol used depending on the actual ground connection. Now, every circuit only allows us to utilize the earth ground symbol, so it may not be exactly appropriate to use the earth ground symbol when we're looking at circuit schematics. There are three different types of ground symbol. We have earth ground, chassis ground, and signal ground. Now, all of these symbols mean ground. They mean the same thing. All of the ground symbols mean that the charged electrons want to flow to ground to achieve a zero voltage, or in other words, get rid of their additional charge. The only difference between these three symbols is where you would use them in a circuit schematic. Signal ground symbols, for example, will be used in digital logic circuits. Chassis ground will be used to show where a ground cable is connected to a chassis of a certain device, such as a metal case surrounding the electronics inside it. And earth ground is as ground as you're going to get. It's literally metal stuck into the ground of earth. And this is generally used in your home as a safety ground for the AC power that comes into your house. But ground is still ground regardless of its symbol. It's a place where the charged electrons want to go in order to get rid of their additional charge. And again, the ground symbol is only there to tell someone who is reading a circuit schematic where the ground reference points are. Okay, so every circuit here, technically, without this ground symbol connected, you already know where ground is. Using conventional current here, electrons will flow from the positive through the circuit and through anything in its path as long as it's forward biased, and the electrons will then return to the negative side of the power source. In this case, the negative part of the power source is our ground, because ground just means that this is where the electrons want to flow. Now, every circuit forces you to use the ground symbol just so that anyone reading a schematic can understand where ground is. Now, of course, it's easy to understand where ground is in simple circuits like this. So we've pressed play and we can actually observe that the electrons are flowing from the positive side of the power supply through our LED and towards the ground symbol. However, what I can actually do is put the ground symbol on the ground point of our circuit, and this actually makes it easier because we don't then have to have lines tracing all over the place, returning to the same ground point on our circuit schematic. And I'll show you how this works. I'll take multiple LEDs and lay them out on screen. We'll connect the positive sides of all of the LEDs to the positive rail of our power supply. Now, you can imagine this being much bigger and other different connections that I would then need to draw the connection going from the negative on every single negative point of a device to return to the ground or negative side of our circuit. And that would look like this. Now, that isn't too messy, but as I said, if there are a lot more components on there, it's going to get quite messy. So because we're drawing a schematic, we don't have to physically, or in this case virtually, connect all those wires together. We can actually just tell every circuit that the negative sides of all of these components are referenced to our ground point. The main ground point being here, and every other component with a ground symbol on the end. Every circuit will then know that the negative side of all of these components will be referenced to the ground point here. So if I now press play, you can see that in a schematic, every circuit knows that we have referenced the negative side of every single component in this circuit to this ground point here. So we can see the electrons are flowing out of every single one of these components and down to the ground symbol, which of course is here, and then it's just returning to the negative side of the power supply, and the circuit repeats. And just in case you had the thought, where do electrons actually go when they go back to ground? They go exactly there. They go to ground and they stay there. The electrons, as far as they are concerned, have done their job. They've passed through the components and lit the LEDs or dispersed their energy within the circuit, and once the electrons leave the circuit, they are then at 0 volts. They no longer carry charge, and we can forget about them. As with a battery, a negative terminal, that's also known as ground. It's not a physical ground into earth, it's just the negative side of the battery, because the positive side of the battery is positively charged. The current moves towards the negative side, loses its charge, and stays there. After the battery's dead, basically the chemical reaction has stopped because there is a lack of charge due to a lack of electrons. So hopefully I've made sense of the ground symbol to a lot more of you guys. If you have only recently joined this channel, make sure you check out the Simply Electronics Basics playlist, where there are 23 previous episodes where you can learn in this visual format right from the very beginning. Make sure you leave your comments below if there's anything you want me to explore. Hit like on this video if you enjoyed it, and make sure you subscribe for more videos in the future.